Good evening, everyone. So, welcome back. Today, we will see another interesting topics in series of our Python program. So, this linear regression is one of the machine learning technique, we can say. So, that we will be seeing how to do the linear regression with the scikit-learn. Scikit-learn is again a machine learning library in Python. So apart from that, we will be seeing data visualization with Seaborn. This is actually a library which is built on top of matplotlib. So for different purposes, so for advanced graphical visualizations. So as of now, we have seen Plotly, matplotlib, and this will be the third one. So depending on the requirements and depending on different type of charts, we will be using different kind of visualization modules in Python. So Seaborn is mainly for plotting bubble charts, so that we will be seeing. And before that, as usual, what we will be is the learning today. Let's see. So today, what we will be doing, we will be using movies data. So it's like where the movie budget and revenue after budget. So we have already provided a CSV. So we will be using that CSV and we do the analysis on top of this. So yeah, so like a prediction of, for example, the main thing what we will be, the question is, so do higher film budgets leads to more revenue in the box office? So it's like if a film is created with very high budget, does it gives sufficient profits? So revenue is nothing but the profits, right? So yeah, it's like so using linear regression, we actually predict if movie spends more, I meant to say more on the budget, like to make the film, will it get a revenue or not? So in this session, what we'll be reading, so we will be dealing with data visualization and how to run and interpret a linear regression with scikit-learn. Scikit-learn, again, this is a machine learning algorithm. I am saying a linear regression is a machine learning algorithm, one kind of uh, algorithm. So, and scikit-learn is the tool to implement that. And again, the scatter plots, and we will be creating bubble charts, and we will be seeing float division also to convert our data. So as usual, we download the zip and add it that notebook file to our Google Drive, open it as a Google Collaborator notebook, and add the data to data tab, the CSV file to the data tab. So today, mainly, we will be looking on the data side only. So we will be looking different kind of data cleansing techniques. So this we need to be keep in mind. So to start any machine learning or any kind of analysis, so the preliminary data analysis is very important. So we need to clean our data. We need to get the exact data what we need. So we need to remove nan values, duplicate values. Otherwise, whenever we do a regression or machine learning plotting, so whenever we do predicting, so it will give us the false outcomes. So because our train data is not correct, so obviously our prediction data is also won't be correct. So to eliminate that outcome, we need to do our data exploratory data analysis before implementing any machine learning algorithms on our data. So here are the questions. So let's take. So It's like how many rows and columns are dataset contain? Are there any NaN values? What are the duplicate rows? What are the data type of the columns? And we have a challenge to convert our budget production data like these columns to numeric format by removing a dollar sign and comma sign. Okay, United States. So and again, we need to convert our release date to pandas data type. So let's go to our collab notebook. So they already I have uploaded in my drive, and I just opened into Google Colab, and then I uploaded the data cost revenue underscore dot CSV to under the data tab. Now what we'll be doing, we will be doing our preliminary analysis. So because we need to load the data, by default the pandas is the library we will be using, and these are all matplotlib. So this we will be seeing later, not in today's session, maybe tomorrow's session. So but let's import everything. So this is again different for displaying data. This also we will be seeing later today. I meant to say not today, maybe tomorrow, because as of now, today we will be focusing mainly on preliminary data analysis only. So again, we are reading our data into a data frame, into data frame. So how many rows are there? So uh, we have done it multiple times, but let's redo it again. So, yeah. So first of all, just loading data, we are checking. There are 5391 rows and 6 columns. And if you see the sample, so sample is random data. Head will give top 5 data. The tail will give last 5 rows data. So the sample will always be random. So it changes. If you see the index, it will changes. Varies whenever we run it. It will varies. So we are seeing the column data also: rank, release date, movie title, US production budget, US worldwide gross, US domestic gross. So there are 3 columns: budget, gross, and US domestic gross. And we have movie title and release date and what is the rank. So we are checking the last rows tile. So we are checking if any NaN values are there, because as of now we are not having any NaN values. We are getting false as our output, because we are seeing any is the method we call on our data frame, and we are checking values in that any are there. And we are again checking duplicated a method we are calling on the same data frame, and we are checking. So any duplicates, it's like we are giving false. It is we are not having any duplicates also. There are no NaN values also. So even if you see, it will see non-null. So all columns is having a non-null object, non-null, non-null, non-null. And we have the data types also info. It will give. So there are 5391 entries and index is 0 to 5390. There is one with int and remaining everything is an object. Now, this is the first preliminary analysis what we have done. We have got some understanding what are the data we have loaded. into our data frame. So now the second challenge is we need to convert our three columns to a numeric format, because if you see here already we have did the same thing for in previous sessions by removing dollar, not dollar, we have removed the comma, right? So we will be using the same thing here. So what we are using string formatting. So but here what we will see, we just write a for loop. So for example, we need to remove all these columns, like all these characters, and from which columns we are preparing a list. Now what we are doing, we are looping over all these columns. First column for loop and for the character. So what we are doing, we are replacing each character with empty string. So here again, if you see here, the column name is this one, equal to, for just for our reference purpose. For example, if we just to show us, so the column is nothing but for the first loop, it will be union production budget, and the first string will be comma. So we are replacing comma with this one, all this column, the first loop. But in the second loop, in the second for it will replace, for the same column, it will replace a dollar with empty string. So just for our reference purpose, I'm saying. So once this for loop is ended, because for the first column we have done the same thing. Now it will go back to the next column. So again it will do the loop. So it's like we are running two loops, one inside other. And what we are doing, once the replacement is done, like for both the characters, we are actually converting to numeric data type this column. So if I just run this, now we run here. So whenever we see this, so here it used to be $15,000, right? So here there is no dollars, or we are not getting any. So okay, let's see head dollar. Okay, because I have already marked replaced, right? So that's why we are not getting a dollar signs here. But yeah, generally we will get a dollar sign and commas. So because we have replaced already and converted to numeric data type, we are not getting it. Yeah, now the final challenge is like to convert release date to pandas date time. So already we know we need to convert to date time this release date. So if we not, it will be in a string format, but when we convert to this format, it actually does a format got changed. So by default, it will go to YYMMDD format. Now on top of that, now when we run the info again, so now the release date is datetime object, datetime data type, and all the four last three columns are integer data types. Yeah, we have done the conversion. Now, the preliminary analysis is done, so we have explored the data and cleaned the data. There is no null values and there is no duplicate values, and whatever the data we have loaded. Now, what we will be doing, we will just go to the next part. So now, what we have another like another challenges. So what the challenges are? So what is the average production budget of the film in the data set? What is the average worldwide gross revenue? What is the minimums for worldwide and domestic revenue? Are the bottom 25% of the films actually profitable or are they lose money? So what are the highest production budget, highest world gross of any film? How much revenue did the lost? So for all these questions, we have a single answer. Let's call describe. If you see here, so for all the columns, so a rank except movie title, we have whatever like when a date column is also got the descriptive statistics. So here the count, uh, like the minimum budget, like so there is a minimum worldwide gross and domestic worldwide gross, and what is the maximum worldwide gross and domestic gross, and what is the production budget of the maximum. So what is the minimum thing? And if you see here, actually, is this using this budget, how much it got? Actually, this is profitable. So let's understand all this. So, yeah, so what is the mean, the average production budget, the average worldwide gross, and the average rank? So the average film, this is the cost about $31 million. If you just go to our notebook, if you see here, it's like $31 million, but average worldwide gross is like $88 million. So it's just an average, but so it's like generally if the film is making with an average of $31 million, we are the revenue it is generating is around $89 million. Yeah. The minimum domestic makes sense if the film not is screen not is cancelled. This number would be expected to see here. Yeah. Yeah. The highest production budget was this one, and the revenue is like $2.7 billion it got generated. At, at 25% quarantile, so if you see it's like $5 million, and it's like just only 3.8 million dollars it is generating revenue. So at the lower side. So now let's go to the next. So which film was the budget? So generally, because we already know this is the minimum production budget is like $1,100. So whenever we just filter it out, so using a dot notation, we are filtering it out on US production budget column equal to. So my date withdrew. You have never heard about this. So this is the movie title where it is the having the least production budget. Now we will be checking having the highest production budget. So what is that? So yeah, it is Avatar. So yeah, no, want to say at that time up to 2018, what are the data we have is still 2018. It's no wonder Avatar is the highest production budget and it is having the highest gross collected. So now let's see how many gross. There is no domestic revenue. I meant to say. So there is no oh, this one. In the years, if it is not uh, uh, actually grossed, but it internationally it is grossed. That also we will be checking. So as of now in US, how many films grossed zero domestically? That is in United States. So in United States, we are having the domestic gross equal to zero. So number of films what we will be doing. Yeah. So yeah, there is movie title Aquaman, A Wrinkle in the Amusement Park. The release date is also different. So production budget. So this can be actually different. So there are actually 215 films, 512, sorry, which has domestically zero. So for example, this may not be released at that time, so the production budget is zero. But there are few other films. If you see here, there is this film. It might not be an Hollywood film. It can be of different language, which crossed worldwide, but there is no domestic. So it didn't got released in US itself. Yeah. So there are few other movies where might be they got cancelled also. So there is no zero. So now let's see how many films cross zero worldwide. What are the highest budget films that had no revenue in internationally? Okay, again the same thing. Now using worldwide gross equal to zero. So again there are around worldwide there are 357, and in that Singularity is the film which is having highest budget, but the gross is actually zero. There can be many reasons. So either the date is not correct, or it is not yet released, or it might be meant to say it might be cancelled. The same thing. Yeah. And this is what we are talking about. So this Dan Cato is in Deep Andela, which about $4.5 million. There's nothing in the United States. The same thing. So now we have investigated. Now let's go to the next part. So on filtering on multiple conditions. Now what we will be filtering on multiple conditions. So on single condition. But what if we want to give on multiple conditions? For example, that is both internationally also it made a zero and gross is also domestic is also zero. So how to filter on this? So it is very simple. So directly we can use lock property, and here we need to give this both the filters domestic gross equal to zero and domestic gross and using an bitwise and operator. So why we are using this? Because we already learned a NumPy. So NumPy is like pandas is built on top of NumPy. So that's why it actually works as a bitwise operator. So it's like whenever this gives true and this is true, then only it will filter that records. Otherwise, if it is false and if it is false, then it don't filter that records. So, and again, we need to be very careful. We have to include parentheses. Otherwise, the operator precedence will take care and we don't get our correct results. So here, if you see, we have included our filtering conditions in parentheses so that it will be evaluated first and then it will be doing the operator and bitwise operator precedence. For example, if I just don't give and run, either I will get an error or I will get a some weird. Yeah, yeah, yeah. So this is the main value error because the operator precedence will be first it evaluate this and like bitwise operator and it's like it will give there is no uh, correct ambiguous, so it don't result in a correct value. So that's why we have to give our filter conditions in parentheses first, so that they will be evaluated first, and then it goes to the bitwise operator. So here what we have got it. So we just got what are the there are uh, films which was released internationally, but it is not released in US. So the films can be of different countries, maybe French, Spanish, different countries. So this is one way of accomplishing. So the next way is like we can use query function. So you can directly use on our data frame directly. For example, the query function. It's just like an SQL query. So this is again a very handy function. Again, just like SQL, I'm saying, right? So yeah. So now just what we are doing, we are just using query. So here we are giving a total like a domestic gross equal to zero and US domestic gross not equal to 0, and we are just keeping that filter condition in single quotes. Now the same thing it will give us. It's like 155. So we are seeing a tail here. We are seeing head here. So that's why there is a difference. So what if I just change it to head? The words should be same. So there should not be any difference on on the data what we are fetching. So now, okay. So let's check what are the fields which are not released at the time of data collection. So it's like May 1st, 2018, the data is collected. So, so which are not released and how many films are included in the data that have not chance to be screened at the box office. Okay, I think this I have got an issue because the type error issue because I didn't convert it to date type first. So directly I have. Now here what we are doing, we are just filtering it out. What are the release date is greater than the first. What whenever we have scraped that like the data using web scraping. So at that 2018 May 1st. So whatever the release date greater than that date. So those are the unreleased movies. Yeah. So there are nearly 7 movies are there. We are just using length because from last also we are using length operator. So length will give just a number of records of the data frame. Yeah. So here, so now we will be using data underscore clean data frame. We will be dropping this all these indices. So we are dropping all these indices because those are not released and there won't be any gross. So even if we take into our consideration, it is actually not a correct data. So that's why we are dropping using a features index. If we are checking again whether they got dropped or not. So we are just taking the rows. Even we can just length of data minus length of data clean, that also will work. So yeah. So we have dropped all that. So we will be using a data underscore clean from now to do our further analysis. So now the final challenge now before moving to Seaborn. So this is the final challenge. So what is the percentage of films that cost exist the worldwide gross revenue? So it's like just again we are just using the filter condition. So using the lock operator. So the filter condition is the production budget is greater than the worldwide gross. So that means uh, so the production budget is greater, but uh, uh, no, it is not done good at box office, so we don't get any profit. So it is in a loss. What we are doing just so, yeah. So just we are creating this one data frame, and we are using length because it gives number of rows and divided by total number of rows. That's the percentage, right? Number of by total number of things. So the same thing here we are using query. We also can do, and here instead of length they have used shape. So the same thing, the result will be same. If you want in percentage, we have to multiply with 100. So generally it's like 37%. Uh, so 37% of the films didn't actually returned whatever the production cost is. So it is like very huge. So it's like only 60%, not even 60. So it's like I think 63% only films are making good. But 37 films are not didn't make any profit. Even they went into loss. So some can be equal to, or we can just give tolerance levels, and that's again a different part. So yeah, this is what for today. So we have did our data analysis on all this. So now we will be using this data frame. So to clean uh, from tomorrow, this data frame whatever we have done until today. So yeah, this is the plots we are talking about. It is again a scatter plot. Actually, this is the same thing. This is the bubble chart actually. Like it's a three-dimensional chart. So that how to do that we will be seeing later. So yeah, so this is the regression plot. How we will be plotting that. And yeah, so we are estimating the revenue of a $350 film is around this one. So it's like the estimation already we have said, right? So this also will be seeing our model, linear regression model, how it actually performs. But yeah, so this one by one we'll be seeing on next sections. That's it for today. Thank you.